Alright, so this is AP Stat Quideo number 4, and I'm Jackson Gutshall, and this is the basic question, and it says the Gallup poll asked a probability sample of 1,785 adults whether they attend church or synagogue during the past week, and then you gotta suppose that 40% of the adult population did attend, and we would like to know the probability that an SRS size of 1,785 would come within plus or minus 3 percentage points of the true value. So A is asking what the mean and the sampling distribution of p hat is and the standard deviation. And so since 40% of the adult population attended, the mean's going to be over here at 0.4. And then to find standard deviation, you do this equation right here, p times 1 minus p. So there's your p hat's still at 0.4, 40%. 1 minus 0.4 is 0.6. Multiply those, divide them by 1,785, take the square root, and the standard deviation is going to be 0.0116. So then B asks, explain why you can use the formulas for the standard deviation of p in this setting. I said you can use it because the U.S. population of adults is over 10 times the size of the sample of 1,785. So there's going to be a lot more adults in the U.S. than the sample size they took. So that has to do with the central limit theorem. Come down to C, and you're going to want to check that you use the normal approximation for the distribution. So you check it up against this equation. You take the sample random sample times the mean population, get 714, and that is greater than or equal to 10. So then you come down here, do this equation, and that gets you out to 1,071, which is also going to be greater than or equal to 10. And you find that by doing the n 1 minus p, so you do 1 minus 0.4, and so it's still the sample random sample times the 1 minus mean value. So then for D, you're going to want to find the probability that p hat takes a value between 0.37 and 0.43, and will an SRS of size 1,785 usually give a result p within plus or minus 3 percentage points of the true population proportion. So you're going to come down here, p hat's got to be between 0.37 and 0.43. So you come up here, your minimum value 0.37 minus the mean population over the standard deviation. The z's got to be in between that and 0.43 minus the mean over standard deviation. So you work those out and you find that p is going to be in between negative 2.586 and positive 2.586. So 99% of the samples will end up falling within 3% of the population with that 99% confidence interval. And you will get a confidence interval of over 0.994. And that's it for the basic question. So now we'll come to the advanced question, and so A on the advanced question says construct and interpret a 95% confidence interval for the mean difference of the estimates of the two methods in the population of tires. So for A, you come over and you start out by listing 4.56, which is going to be the mean of that, plus or minus 2.131 times 3.226 over the square root of 16, and you will get the interval, the 95% confidence interval of this when you do add and subtract, and it's going to be between 2.837 and 6.275. And so there's a 95% chance that the mean is going to be between these two numbers, and that's A. And then for B, it's asking, does your interval in part A give convincing evidence of a difference in the two methods of estimating tire wear? And I said, the weight method gives larger numbers than the groove method since the intervals are both positive, so the weight method is going to give you larger numbers than the groove method. And now the AP question, which is going to be the last one here. And it's about the golf balls. And A in the AP question asks, if the manufacturer sets the mean distance traveled to be equal to 288 yards, what is the probability that a ball is randomly selected for testing to travel that far? So you're going to come over here, plug your numbers in, and then you're going to come over here and get this equation that Z's got to be greater than 291.2, which is the balls will travel as close as possible, minus 288, which is what A is asking, over 2.8, which is going to be the standard deviation. And then you will come over here, and that works out as to P, or this works out to be 1.14, so Z's got to be over that. And 1 minus 0.8729 equals 0.1271, so that would be the answer to A. And then B is assuming the mean distance traveled is 288 and the 5 balls are independently tested, what is the probability that at least one of the 5 balls will exceed the maximum distance of 291.5? So the distance needs to be over 291.2, which is why that equation is set up like that. That's going to be the same as 1 minus P. The distance is going to be less than or equal to 291.2. So you find both sides of it. You come down here and work it out, and the probability that at least one will exceed that is going to be a 49.32% chance that at least one ball exceeds that. Part C asks, if the manufacturer wants to be 99% certain that a randomly selected ball will not exceed the maximum distance of 291.2 yards, what is the largest mean that can be used in the manufacturing process? So you come back over here, you're testing a 99% confidence interval to find the mean. So they give you the maximum of 291.2. Mean is the variable that you're solving for. 2.8 is the standard deviation, and that's going to equal 2.33. So plug in the numbers, and that equation comes out to the mean equaling 284.676. So that is the largest mean that can be used in the manufacturing process. Thank you.